So the first thing I wanted to say is that the old way that I used to be installing when we're doing energy analysis, what I'd like to do is to keep it in the same vein that we've been using and keep it in Grasshopper. And the reason for that is that then we can use Ladybug and Honeybee. I find those to be the most robust tools for energy analysis. And again, we already talked about this kind of feedback loop that you get with the design process when you're using that compared to what you would get with like a typical energy analysis tool. Um, Thank you for finding this problem for me or presenting it to me. So the old way I used to do it was to go into food for Rhino, same way you would download any other kind of add-in for Rhino. And I would type in Ladybug and go from here and click on Ladybug Tools. And then I'd scroll down and download the latest and greatest installer. So the issue that I had was actually with the latest release, which was only released a couple of months ago. And the reason that I had so much trouble with this is that in the past, installing Ladybug, installing all of your Radiance tools and everything from kind of the Green Building Studio was, or there's like a suite of tools that includes all of this. It's actually a little bit of a lengthy process, and that was almost going to take up like an entire class of just how to configure Ladybug and Honeybee to work right for everyone. Through that, though, they have moved all of these tools to a website called Pollination. And I'm going to say Pollination, Ladybug, Pollination, Grasshopper showing up here. So Pollination, Ladybug tools would also work. And then it takes you to this new website that's www.pollination.cloud. If you click on the home page, they've moved everything onto this really nice they've moved everything to their own website. They've been working a lot with the feedback that most people's problems are installing the right version with the right studio suite, all of this other stuff. So if we come up in here to products, we come down to Grasshopper plugin. We can download the latest version. It will open up a little bit of a new tab, and we want the one for Grasshopper. Another nice thing with the one for Grasshopper is that it's free. There is Ladybug for Rhino and Revit. In the one in Revit, I believe it runs out of Dynamo, so it's a similar thing to the Grasshopper version, except for it's quite a bit more expensive. So on the Grasshopper tab, you say download for free. It starts to download an exe file or an installer. And if you click on that and you run through the installer, it will install Ladybug, Honeybee, and all of the necessary design suite tools that we'll need for this class and to do kind of your basic energy analysis. So much more user-friendly version of that. So I'll just click on the installer and kind of run through that really quick here. I already have it installed. The first thing it's going to do, because it's an exe file, it's going to tell you that Windows, and it depends on your Windows setting, but most of the time Windows doesn't want you to run an exe file or executable from your downloads, because that's an easy way to get viruses. If you click on more info here, though, it shows you what it is that the executable that you're going to be using, and you click run anyway. And then it'll bring up your kind of typical install user interface. You'll run through the setup, click finish, and when you're done, you'll have the Ladybug and the Honeybee tools in Grasshopper. One thing I would say though, before you run this installer, make sure that you have uninstalled all previous versions of Ladybug or Honeybee that you might have. And the best way, and you'll just go through this, I'm not going to run through the whole installer. If you do get hung up there, let me know. But the best way to do it to make sure that you don't have Ladybug or Honeybee is first open up Grasshopper, make sure you don't have Ladybug and Honeybee as little tabs up there, and I'll just open up, well, I don't have to open up anything, just open up Grasshopper. And then the other place that you want to check is in your specials folder in Grasshopper, just to make sure that there's sometimes when you run an uninstall of Ladybug, it won't remove everything. So up here I have Ladybug and Honeybee, which are these kind of two tools here, LB for Ladybug. So I've run that installer, so I do have them. But before you run that, open up here under File. You'll come down to Special Folders, and you'll go to Components folder. Is one place to double check. And we can see in here I don't have anything associated to Ladybug. The other place that you'll want to check is go to your User Objects folder and make sure that there's nothing related to Ladybug in here. I have a whole bunch of stuff from Gizmo. We'll get into that when we get further into the environmental analysis, which I'm hoping to do next class. I'm hoping this is kind of our last class of Rhino Inside. So with that, I'm going to fire up Revit, and we'll kind of go from there. And
another thing too, Chris, with downloading the pollination tools, what you forgot to go over is that you have to like create an account for it, which is really simple. But
oh yes, thank you.
It'll ask you to make an account.
Great. Does anyone have any other questions about that right now? So what I'm hoping is before next class, when we get into the energy analysis, that everyone takes a chance to download the tools from the pollination website and get those installed. Again, you'll have to create an account. You don't have to pay anything for it. So if you find yourself, if you find out they're asking you for money, you're in the wrong place. It shouldn't be until you actually download it and download the version for Grasshopper. It's the one we'll be using in class. Again, please make sure everyone kind of gets that handled before our next class and not after. And here we go. I'm actually, for this one, I'm just going to open up a brand new project. And I'll do Imperial Architectural for fun. And right now I'm just firing up Rhino Inside. What I wanted to show you before that crashed, and I'll do it now. If I come over here to the Visibility and Graphics Overrides, I click on Edit, and the other way I can get that, if I just hit VG, type that on the keyboard, it's the hotkey there. I'm going to go down to Site, and I can either scroll down there, or I can just type S, and it'll make me jump down to the S section. Open that up, and I want to see the internal origin. And so this internal origin here, right now I haven't done anything to this file or this template, so we can see that's in the direct center. These are just elevation views, so these are just empty elevation view tags. But then in Rhino, that internal origin is directly related to the internal origin of Rhino. So if I drew, and I'll just show that, or I can show that by opening a Grasshopper here. So close, and I'm just going to draw a circle here. Go 0, 0, 0 for my origin. And I'm just going to draw it about that big. I'm going to reference that into Grasshopper. There's a curve. You can say set one curve. Cool. So now we can see that relationship in Revit and in Rhino. Sorry, I've got to manage my windows a lot better. I don't have two screens. And if I did it, then I couldn't really screen record or share both of those, so it's kind of better here. But if I grab this now, we can see that I have the circle centered on the same origin. If I move this circle up now, we can see it keeps that relationship. And one of the issues here is that my viewport extents aren't letting me see the whole circle. But we can see that kind of direct relationship to both of these origin points. It's very, very important for trying to place your model in the right location. Let's say you already had a building drawn up. That'll allow you to be able to go through and figure out where you're supposed to be placing your Grasshopper geometry in relation to your Revit geometry, if you have any that you're kind of pre-existing that's working there. So with that, I want to get into placing our kind of custom panels that's using that family that we did 2 classes ago that is a adaptive component family. We're going to place that around in here. And for fun, I'm actually going to, I've got a cheat sheet over here that I'm going to do. I'm going to make like some kind of crazy phyllotaxis shape. So I'm going to make a series, and I'm just going to go through this just so we have a little bit more exposure with Grasshopper. For my count is the only one. I'm going to say like 136 for fun. And I do want to drag this over. I'm not too concerned with Revit yet. Then I'm going to say construct point. And I'm going to say, I'm going to get 2 expressions because I'm going to use some math to do this for fun. And I'm going to say the first expression is actually going to be a variable t. And I just change that by right-clicking on it, and I can change the name. And then if I double-click on this, I can say the cosine of t times t. Okay, I'm going to copy that down, and for this one I'm going to say the sine of t times t. I'm going to open up my bifocals so everyone can see kind of all the names here. I'm going to plug that series into each one of these. So now I have 2 expressions. One is the sine of t, one's the cosine of t. I have a series of numbers from 0 to 135. I'm going to plug those in for my x and y coordinates, and I get a nice pretty phyllotaxis. I know this because I know the equation for a phyllotaxis, which if you look it up is the function of x and the function of y is t cosine of t times t. And then for my z value, I'm going to open up a kind of a fun tool that we haven't gone over that is super useful. It'll let you kind of tweak things around in a fun kind of dynamic way. Is we're going to use a graph mapper. And I'm going to take this series between 0 and 135 and remap those into a series between 0 and 1. So like if I right click on this graph mapper, I'll come down to graph types, and I have a whole bunch of different types of graphs that I can use. What I'm going to use is Bezier graph. And for the series here, only thing I'm doing is I'm changing the z-coordinate. Right now our z-coordinate is left to 0, so we can see we have like a really flat shape. Our phyllotaxis is really flat. And I just want to make this like a little bit more 3D for our Rhino Inside. And so I can say remap. If I come in here to my domains, I actually want to remap all of my numbers in between 0 and 1. So the value is going to be the value of my numbers. I can get the bounds, which is going to be my minimum and max. Again, another piece of math up here in domain is going to be where you find your bounds. And what this will do is it'll give me the lowest. It'll give me a domain from 0 to 135, which makes sense because we have 136 items in here, and hopefully everyone remembers why this is 136 and my maximum is only 135. because we're starting at 0. So we only have that, that's our max. So that'll be the source domain. And then for my target domain, I have 0 to 1, which is what I want. So I can put those mapped numbers in here. And now you can see on my graph mapper up in the corners here, this is the domain of the graph of each one of the scales of the graph. I can right click on that and you're able to change what that domain is. We could have put those numbers in as like a hard number, but I don't want to do that because if I decide to change how many points I have on my phyllotaxis, I'm effectively changing the bounds of what that is. So I'm kind of bringing everything to like that. It's kind of the same thing as like reparameterizing our surfaces. We're doing a little bit of that for our z value. I'm going to add a multiplication in here. So I'm going to take what we're getting from that. I'm going to multiply it by a value just so I have a little bit more control. We'll see what happens. This might be not what I want. Plug it into the z. Yep. Okay. So now I can bring this up. Maybe I want this to be a little bit higher. So I'm going to change my max to 200. I did that by just double clicking on our slider. So now I have this like cone phyllotaxis, but I actually want it to be a little bit more fun, and this is where the graph mapper is a blast, right? So if I start to change this Bezier curve, you can see how that's directly changing the shape corresponding to the curve I'm drawing, right? So if I go like this, like the edge curve of my lofted Z is now related to the edge curve of my graph. So if I like flip that, right, now I've got like this S curve, like S curving in section now. Really fun tool, a whole bunch of different uses for it. So I've got this kind of pretty little shape that I'm having fun with, just for the example of it. I did want to do just a little bit of Grasshopper work so that make sure we're knowing we're working in Grasshopper, Rhino in Revit, not Revit with Rhino. And then to make this into actual three-dimensional shape, I'm actually coming to the meshes. I'm going to go to triangulation, and I'm going to make a Delanoy mesh. I think that's how you pronounce that. Sorry, sorry, Dr. Delanoy, if that's not right. And then I get this kind of cool shape. So I'm just going to hide this stuff for now. I actually don't need that curve. So now I have kind of like a fun little cone thing. You know, I don't know. I don't know how good it is or how bad it is, but we can kind of play around with what it does now. And same thing with the graph mapper. We can kind of play around with like how that works. Hopefully that is a little bit more fun than me just giving you like a column. I don't know. So from here, we want to get that into Revit. So if I come into my 3D view, we can see that I already have a bit of a shape in here for what that is. Now this isn't actually Revit geometry. I can't select any of this. So now is where we're going to want to use Rhino Inside to now make this actual Revit geometry that we can then start to pull some information out of and, you know, do the BIM. We're going to BIMinize this shape. That's not a word. One of the things that I'm going to want to do, so I have my mesh. I'm going to want to get my mesh faces. So I'm kind of, like I said the last time, because I'm going to want to use native Revit system elements, I'm going to have to extract the geometry that Revit wants to be able to put those into a Revit shape. Otherwise, I could use a direct shape and just pipe the direct shape right in there. It's going to give you your geometry. It's not going to have, you're not going to be able to manipulate it in Revit the same way you would, and it's going to have a lot different relationship to any of your other elements in Revit. So it's a good kind of bang for your buck operation is to use direct shape as Rhino inside Revit, but it's not as robust as using what we're going to do is use kind of native Revit elements. We're going to build our own family and use that to also bring things in. So I'm going to come into my mesh. I'm going to deconstruct that mesh. And then I can get my faces, and I can deconstruct my faces. And I don't think I want to do that. I want to take this face, and I'm going to get my face boundaries. And to do that, I actually have to come in from my mesh. Excuse me. While I go through this. There is a way to do it through deconstructing the mesh, deconstructing the faces. As we could see with the deconstructing faces, it gives us 4 points instead of 3, which is what we're looking for. So we're looking for each one of these boundaries. Maybe I'll just do both of them side by side so we can see. So deconstruct the face here. And then if I open up a panel, or I make a point, we can see kind of where each one of these, oh, nope, it won't let me do that. And that's why we're not using this deconstruct phase, sorry. And the main reason is that the values it's giving us for these corners actually don't correspond to a direct point. So I can take these boundaries then, and I can explode that curve, coming into analysis. Deconstruct curve. No, control points. Sorry. This will give us all of the knots within our shape here. So I bring that in. You can see now we've got kind of all of our intersections, but these are all related to like a face boundary that has 3 sides. So this is actually like a triangle for each one of these. And then for our points, if I bring that in, we're actually going to get 4 points, 0 to 3, instead of 3 points. And the reason for that is that this face boundary closes itself. So it has point number 3 and point 0, if we look in our panel, are identical. So it's negative 222, 11, 151, negative 222, 11, 151. But we can see that for each one of those panels, we have our own list of points. So what we're going to do is we're just going to drop out this last point because it's redundant. So in order to do that, I can come in here to my sets, and I can go to col index, remove an indexed element from a list. I'm going to bring that in for my list. And then for my indices, I want the last index. And so I can either type in 3 because I know that that's the last one in there, or I can do another little trick by putting in a -1. And does anyone know why putting in a -1 is going to get me the last object? I see some heads shaking no. Alright, so the reason for that is if you think about getting an index, knowing that the index number starts at 0, let's say we have like variable length lists, but we always want the last one on the list. In this case, we have sets of 3 for every one of them, so we don't have to worry too much. But let's say we had one set of 4, one set of 5, one set of 3, one set of something else, is that we can always get that last one because we're actually wrapping backwards. By putting in a -1, we're actually getting 0 minus 1, which will always give us our last point. Does that make sense to anybody? It's like, kind of going backwards in the list instead of forwards. It's kind of like a timeline. So now once we've called those out, we can go into a panel. And now we'll see we only have 3 points, 0, 1, 2, for each one of our panels. And that's what we want, because we're going to use those to correspond to our Revit geometry. And does everyone have an adaptive component that they built from kind of that first class that we went over? Does anyone not have it, I guess? Does anybody not have the adaptive component family built? No? Everyone's got it? Okay, cool. And I think I have it here, so I can say Oh, where did I put that? Rhino Inside. Revit. I'm just going to import that family. Adaptive triangle panel. Again, if anyone doesn't have it, kind of raise your hand and I'll just email it to you. Back up, a little bit of window management here. So now it's asking me to place one of these. I'm just going to place one to make sure that I have it in here. And as we can see, the way that I had to place that, I had to click on each one of these points to place that object in here. That's why we're extracting the 3 points from our Rhino shape, is so that we can translate that 1, 2, 3 directly to this shape. So now I'm going to come over and go into the Rhino tab, which I always, or Revit tab, sorry, that I always seem to misplace. And if we come in here to build, we can say add component adaptive, and it's going to ask us for the points, and then it's going to ask us for the type of adaptive component that we want. So our list of points now, we can see if I get a param viewer, we can see we're going to have a whole bunch of branches with 3 items in them, which corresponds again exactly to this adaptive triangle panel. So I can bring those in for my points, and now I have to make this type. And I believe the way I do that is to come into element type picker right here is one way. And then I put the family name where it says family name here. I'm going to say adaptive. And I'm just typing in exactly what I have it named over in Revit. I can see, because I have that adaptive component selected, I can see what it is in the properties panel. Triangle panel. Okay. And then hit enter, and now we can see it found that for me. I also have a drop down, so it'll find stuff that's similar. So if you say like chair, and you have like 100 chairs with that name, it should be able to find that for you. So I bring that into my type, and now we're gonna let it think. And hopefully I don't crash my computer. Shouldn't crash a modern computer. So it's going to be thinking now. Now it's placing one of these adaptive components at every single one of these vertices, these triplets of vertex that we have, that we extracted out from that kind of previous step in Grasshopper. And we'll kind of let this think. And after we get these panels in, I'm going to show you how to do like beams or columns. And if we can get through both of those today, I'd be really happy, because that should wrap up kind of the main components of using Rhino Inside. I might go into editing families, and there we go. Cool. So now we can see in Revit, I have all of these panels, and if I click on them, you can see that's native Revit geometry. This isn't some random shape. And then I can come into this family if I wanted to, and I can put in a ton of parameters. I can use lookup parameters, I can use project parameters, I can start linking my Revit parameters together, I can generate schedules of all of this, I can extract edge lengths of each one of these panels, I can put all of that into a schedule, I can get the Z coordinates of each one of these, I can get the area. See, so I already have volume, right? 37.55 cubic feet. I could then do another operation to get the area, because volume, is a function of depth, and we've set that depth in the creation of that family. So we could literally divide the cubic feet by, the depth that we have, and then it would change it into square feet instead of cubic feet. So, fun stuff there. Another thing that now I can turn off the preview, and I can come over here to my graphic display options, And I'm going to turn on ambient shadows, and I'm going to cast shadows just for fun. And so now I get a little bit cooler visual of the shape just by virtue of turning on my shadows. And of course my sun settings are based on the view. So if I come down here, there's a sneaky little sun with the sun turned off. If I click on that, I can go to sun settings. I'm just going to go to a still, and we'll maybe use like, what is it, fall equinox is the closest to where we're at. So now I've got these. I can also delete this panel. Again, I was just using that to make sure that I had it in here and that it was working and kind of flexing the way that it should. And so now what I want to do is I could either go into this family and actually build like a window frame into this. But if we think about this structurally, there's probably going to be like a primary beam structure for each one of these. And then that window frame will then set into that beam structure. So we're going to build the beam structure first. And then if we have time, we'll come in and we'll edit this family and make it, super realistic. We'll have like gaskets and window profiles, and because that's what Revit does really well. So we can see too, we've gone dark. We have the dark component, which means it's working. So really all of this stuff here was just about processing our initial, well, not all of it, almost all of it. Just going to do a little bit of housework here so that it keeps things a little bit more tidy. And it's probably going to rethink now. Nope, that's awesome. And we'll remove this from the group. Remove from group. Okay, it's not going to work for me. Pretty much everything here over was just about processing this mesh to get us what Revit wants. So now we're going to do a little bit of the same thing, but only for beams this time. And for our beams, I'm going to have a little bit of fun with this. We can actually get mesh edges. So we'll come in here to our mesh, and we'll say mesh edges. And what this does is it'll let us choose which edges we want. So like naked edges are ones that aren't inside of shape. So like our edges on the top here will be our naked edges, and I'll show you an example of that really quick here. Actually going to move back out into Rhino. So if I get the naked edges, I'm just going to have a little curve container to make it easier for me to see. You can see it's just this edge around the perimeter of this shape, right? And then if I get my interior edges, it's everything on the inside. And this is kind of useful because maybe I do or don't want one or two of those. Like maybe I want to kind of manually choose that edge. Maybe it's thicker or thinner. It'll probably be thicker, right? Like your kind of halo ring will probably have a little more tension in it than the other stuff. I don't know. Just kind of playing around. But you can kind of extract out different parts of that mesh in different ways based on your design. So then we can come back in here to the Revit tab. I'm going to go to Build. I'm going to say Add a Structural Beam. I'm going to bring this out over here. So now it's going to ask us for a curve. And the reason that it wants that curve is because if you think about drawing a beam in Revit, it wants a start point and an end point. So it's a similar thing. We're going to feed in that line that's normally inherent to those Revit beams, but we're going to feed it from Grasshopper and from Rhino rather than the other way around. You can actually hide this stuff too, just so it don't get too much stuff going on at once. I think that'll be fine. So now you can see I've already extracted these curves. So this is a line-like curve, and I don't want it to be line-like. I want it to be an actual line. So if I come back to my mesh, under triangulation, you can actually get Delanoy edges, which is the same thing as getting the mesh, except for it's giving us just edges here. So if I grab this curve now, they should be line. Nope, it's also line-like. All right, we're going to see if line-like works. If it doesn't, then we'll go from there. Because I don't believe Revit will allow us to have like a noodly shape for our beams, we'd have to build our own family that then would be our kind of, I don't know, noodle beam or something like that. Revit doesn't do too well with the curves in the inherent beam families. So the next thing I want to do is I want to load in a beam. So I'm going to go to insert and I'm going to insert a component and I load family. I've got that hidden, so click on load family. Gives me a whole bunch of my categories. If I go down to structural framing, there we go. And I'm gonna use steel for this one, steel and glass, because we're gonna do it that way. You can see I have a ton of different types of structure that I can use. I think I'm going to go with a square tube. Maybe won't be the most. I could use a round bar. Where is that? HSS round. There it is. There's my hollow structural HSS hollow structural section. And for the one that I want to load in, I don't know how big I want this. And I don't like to just blanket in, so now it lets me go through and choose which one I'm going to be using. A 10 by 10 might be too big, but maybe it won't. I'm going to grab in a 10 by 10 by 1/4. I'm going to grab in an 8 by 8 by, or maybe a 7 by 7. I'll grab an 8 by 8 by 1/4. Oops. Don't want all of those. 9 by 9. It's my 10 by 10s. And then I'm going to grab a really skinny one just so if, let's say we can make it out of like unobtainium, we'll grab like a 2 by 2 by 1/4. Cool. Now those are loaded into my Revit project. I can grab another one of these again back into the Revit tab. I need to give it a curve, a type, and a reference level. And I'm not sure if we can leave the reference level blank, but if we have to, we can always grab level 1. So come in here to Revit. I'm going to come into my input, and I want my element type picker. And for the family name, I'm going to type HSS and see what it gives me. And it doesn't give me anything. Okay, so I'm going to have to be a little bit more descriptive about that. I think that there is a family component picker. Yes, so this will let me choose everything that I have loaded into the project. It's a little bit much. If you think about like a big model, you'll have everything in here, but you should be able to type in a search and go to structural. I'm just going to type in struct, and so yep, it shows me my structural framing. But this is a family. This isn't the family type, so I'd actually have to go one smaller than that. One thing this will also let me do is now I can just type in here and say structural framing, and it's still not finding it. Do I have that spelt right? Yep. I'm going to say HSS. Oh, okay. Well, I'm going to go with that one for now. And we'll see if I can then extract the type out of that. Wall system, element type picker. Here's a levels picker. This is what we want for this other side. So we'll pick level 1. So I'm just, again, building these inputs. So there's our reference level. I'm actually going to copy. Can I copy that? No. HSS hollow structural section. There's a space there. I think that I can feed this. Just say model structural section, structural framing, and then I'll just grab one of these. It's not letting me expand this for some reason right now. Okay. Come on, Grasshopper. I'm gonna let me move this. Get some glitches. Okay. Well, now there's a type in there. And I can see that by opening a panel. For anyone who's curious how I got there, I actually do like that method quite a bit, but it's harder to see what that actually is versus here. I can see the name of that being kind of explicitly drawn out by Grasshopper. Over here, it's a little bit more hidden, but the way to get to that type is if you right click in the middle section of the kind of properties, is you can come through and filter out all of the different elements that are in here with kind of a pretty straightforward hierarchy of which one those are. So that's kind of a nice way to do it. But again, it's what type is that? Is that a bead? Is whatever that is? So if I'm like sharing a screenshot with somebody, I'd almost always want to put this kind of down here so they kind of know what I'm looking at. And then I can connect this into the type. And then I'll connect my interior edges. I'm going to leave my naked edges alone for now. And we'll see if that builds it. It says it built a beam. It's giving me a bunch of nulls. And I believe that is because my line-like curve isn't a line. So what I'm going to do is get the endpoints. I'm just going to rebuild this line to make sure that it is exactly straight. So I'm going to get the endpoints. Just give myself a little bit of extra space here. I can delete that. And I'm going to pull this up here so it doesn't get confusing. Now I have a start point and end point. And as we know, line is connecting 2 points. So if I go to my curves and I go to primitive, I can make a line between 2 points, and I'll put my start point and my end point in. And now this should be, it's not a line-like curve before, as we were seeing coming out of here. Line-like curve. Now it's a line. It says L, full-on line. And I'm hoping this is what Revit wants. And it's not. Oh, because I don't have that level referenced. So I didn't have one of these checked. So I was getting that, and I could tell that by that kind of orange linkage here. Sneaky little bit on me. And then again, we'll let it think. It's placing like 500 different beams, which is really cool. Way faster than having to do that manually. Or like, and is way more dynamic than what you probably do within Revit without some kind of add-in or writing your own code.
Hey, Chris, while we're waiting for that to load, I realize I don't have that adaptive component, so would it be possible maybe if after class I could have that sent over, figure out how to locate that?
Yeah, I'll try to package all of this so that anyone should be able to open this file and have all of these things kind of load into Revit. And you can kind of play with that relationship. This is one example of where it might be better, and I'm getting an error here, I believe, because one of my beam lengths is, because it's slightly off axis, it may cause inaccuracies. I don't know if anyone gets that error a ton in Revit, but that'll happen. This is one example where I think that it's going to be more useful if you can kind of open this up and maybe like copy one section, knowing that you have your base geometry is like a mesh or even a surface or something, and being able to like work by like kind of copying and pasting these like chunks of the script apart rather than trying to rebuild all of this on your own. I don't know. Does anyone have any strong opinions one way or another? No. Good. Cool. But yeah, we can see here we have a whole bunch of beams drawn in Revit. We have all of our panels done in Revit. And then if I wanted to come in here, now I can say edit type. We made a material. So I can make this material now. Go to my material library. We'll see what we have. Do I have a glass? Got glass. Say OK. Say OK. And now again, because we built this as a family, we created a type parameter and not an instance parameter for glass. We can change all of that material globally. Another thing we could do, we could actually use Rhino Inside to like pipe in these parameters, and then we could have like rainbow collage, like kaleidoscope view of this stuff if we wanted. But now we're getting, I mean, that's actually a lot cooler than I thought it was going to be. So hopefully this was like in a delete this bean now. I'm not trying to steal its info. And I don't need this level either. I don't know. That's kind of a fun like proof is in the pudding type deal right there. So that was what I was hoping to get through in class today.